SHADEV, first one of 2018. I hope you guys had a great New Year's and Christmas. I'm Anna Sherman. Today we've got Kevin Ard coming up to do an Angular talk, and some Witchcraft may be involved. Announcement, we are looking for Lightning speakers, likely Lightning talk speakers for next week. So if you're interested or know anyone who's interested, you can message me or Brett or Andrew. And then also just regular speakers. We are looking for talks. So with that, let's welcome Kevin.
Thank you. Kevin. I'm here to talk about Angular performance. Sort of the common answer to sluggish UX is OnPush change detection, which that's so basic. There's a million other solutions to it. Grazing the surface. What we have on screen is I put together a workshop GitHub repo. If you're interested afterwards, you can clone that and play around with it. But this is step 5 of that workshop repo. It's kind of just a generic books, authors kind of thing. Load it up with 600 books, and we can still add more. Good, we can filter things. Yeah. So the UX is still pretty snappy, even fairly loaded with 611 books, which is a little obscene to try to show one person at one time. Now, step 0 of the same app, not so good. It does okay with adding books, but even if we click to add 150, it lags for like 5 seconds while Angular is doing what it wants to do. So clearly the difference between here and here is pretty significant. And it got from there to there without touching business logic. There's actually an intentionally overly complex function involved, kind of to simulate bad business code. Sometimes it's unavoidable. Sometimes you just get stuck with something in your front end that you have to work with. So with that, Angular Runtime Performance, a ton of purity and a little bit of Witchcraft. Kind of split into 2 sides of the same coin. There's the pure functions, Memoization, there's that side, which deals with how your functions run. And then later on, there's OnPush and Immutability and redux and all of that. So purity. Who's comfortable with pure functions and pure functions, functional programming? I see a hand or 2 or 3 or 4. So let's go over that real quick, since it's a massive groundwork thing, just to clarify what's going on with purity versus impurity. And now this is not a deep dive into functional programming or anything, but touching on it. This is an impure class. Well, it's a class with 2 impure functions. Kind of something you would see in a shopping cart or something like that. It's just calculating a sales total. But inside of the functions that it needs, there's a whole lot of this. There's a whole lot of outside dependencies. It's not pure. It's unpredictable. There's a lot of uncertainty involved. Now, the same thing, just with a little bit of refactoring. This is the pure version of it. The calculate total and tax for price methods, they don't need anything from the outside world. They don't affect anything in the outside world, so they're contained. Everything they need is passed into them as arguments. You'll get the same result, but as we'll see, there's a ton of benefits from refactoring it that way. Some of the main behaviors that are kind of make pure functions what they are. Idempotent, 4 syllables, 16 pronunciations, go figure. Which is, you can run the function, you can run the method one time, or you can run it a million times. The outside world is going to be exactly the same, so it doesn't matter. Actually, you could go a step further and say they're nillipotent, which, whether you run it or not, the outside world isn't changed. Composable, they're kind of inherently chainable, which is really priceless with. Like if you're trying to filter, sort collections and arrays, things like that. Composability is massive. Instantly testable, which not really important for this talk, but referential transparency is a huge deal when you're dealing with runtime performance. Referential transparency says that the function can safely be completely replaced with its output, which it sounds kind of like what functions are supposed to be anyway, but with impure functions, it's not the case. There could be, who knows what going on in the outside state. There could be race conditions. There could be anything. You can't guarantee that the function is transparent. And virtually everyone is, whether you know it or not, you're using pure-ish functions, if not pure functions. You have things that can be refactored. Kind of the rule of thumb is if it behaves like a math problem, all it needs is what you give it, and all it does is return its result. That's a pure-ish function. You might be doing it impure. I did it impure for 140 years. But with just tiny, tiny refactorings, it can be made pure. So that's what pure functions are. And now what to do with them is free performance. Math problem. What's 532 plus 617? All kinds of things over there to get to 1,149. Ask the same question again, it's 1,149. We skipped all of the extra stuff. We just know that it's 1,149. And that's what pure pipes do. Anytime in Angular, another framework, if you have a controller function that's pure, just extracting it into a pure pipe lets Angular use its pipe optimizations, which pure pipe will only be reevaluated if its inputs change. So for instance, we took those same subtotal calculations, refactored them verbatim as they were, just wrapped them with the pipe annotation, re-implemented them, and now, because of the pure pipe treatment, change detection could run on that component at the bottom. You could have a complete runaway train of change detection. It's only going to evaluate once. Seems pretty trivial with this, but I mean, hypothetically, if your pipe has some business logic that takes 80 milliseconds to run, if your change detection is hitting 1,000 times a second, then that's the difference between 80 milliseconds and 80,000 milliseconds of calculation. And that, in the workshop repo, is step 1, I think. Everybody says use OnPush, use OnPush. Don't use the default change detection. This should really be step 1. Memoization. There's a little nuance hidden in what I said about pure pipes in that the pipe will only be evaluated when its inputs change. So if we have, and like we always do, we have an ng4 that has 1,000 elements, 1,000 child components in it. This specific one won't reevaluate, but a lot of times that can be global. So for instance, in this example, well, it's the exact same code. But so say in our books example, we have these tags here are the output of the complexifier function, which is a totally asinine, unnecessarily complex function. It's based off of a random seed. The seed, it might be 1,000, 2,000, 3,000, 4,000, or 5,000. So in this business logic, with change detection, each one of these would run with every change detection cycle. Now, it may already know the answer to what it's trying to solve. And that's what memoization does, is it's effectively, you're wrapping your business logic with a method that globally remembers the value. If you were to call this pipe with $20 subtotal and a 9% tax rate, anywhere in your app, it's going to remember it anywhere. And so instead of evaluating that function, that could be 3 milliseconds or it could be 300 milliseconds, it only has to evaluate once, which is a huge deal. And then, so that's to do with controlling. Up till now, we're just letting change detection run its courses. We're letting it do what it wants to do, but we're working under the hood to control what happens when it runs, how frequently it executes things, when it calls code, when it just goes off of what it already knows. Track by is it's another kind of overlooked feature, sort of with change detection default versus change detection on push. The default was made for rapid development. It's made for pretty much global use. You can drop it in, start coding, and you'll have something. It's not the most performant thing. So when you get to that point, manual intervention happens. Track by is the same thing. I see a lot of iterators, a lot of ng4s in template code it's running rampant with the default track by. And the track by function is how Angular under the hood figures out if after change detection runs, it has a stack of elements in the DOM, and then it has a difference. Track by is how it knows, what do I get rid of, how do I shuffle the DOM to reflect the model. The default track by function uses object identity, which is kind of a double-edged sword, especially if you leave it at default. Because once you implement OnPush change detection, it's driven by immutability. It won't work without it, which I think we're going to go over eventually. And the nature of immutability is you're constantly breaking your reference. The default track by function, every time you break the reference, thinking you're saving performance, you're killing your DOM mutations because you broke the identity and now it has to rebuild everything. So giving it a track by function gives it it lets Angular know what your model is and when things change. So in this example, I'm using track book by. All track by functions have the same signature. It takes the index, which is it's the index in the DOM array that Angular found, and the model element. So, and the implementation is just, it's right inside of the ng4. And the function itself, all it has to do is return your unique key. So it might be a product ID, or in this example, I'm using the book title. So when you go to implement OnPush, once you break your reference, rather than using the object identity, it'll go by title. So if I have a stack of 600 books, I add 1. Default change detection is going to rebuild all 601 book components. This one is going to rebuild 1. So, and there again, when you're talking about heavy business logic, you're looking at the difference between, 40 milliseconds or give or take 40,000 milliseconds of wait time. So that's another huge deal, and it's kind of, I see a lot of Angular code, and I see a lot of times where I'm not, super developer or anything, but a lot of times where just a simple track by function would save like 6 or 7 seconds of UI response time, and it's literally 3 lines of code. That's just glazed over. So, use OnPush, they say. You're kind of broke into, sort of sped through a little bit on the memoization side of it, and now it's into the change detection. And I distinctly remember OnPush made me want to throw my laptop out the stinking window when I was new to Angular. I was one of the guys I saw on the Q&A board. Oh, I need to use OnPush. I turned on OnPush, and my app wasn't ready for it. So I was running into all kinds of crazy bugs where I could see in the console, I could see my model was updated, I could see my API was running just fine, but for whatever silly reason, the view wouldn't update until I clicked a random spot on the screen. I hate to admit, it took about 6 hours for me to realize, oh, that's not how OnPush works. OnPush, Angular really only provides 2 native change detections. The default is default. OnPush is OnPush. The default change detection works by deep equality, which in the example of 600 books, whenever your model updates, when it's deciding what's updated, it walks all 600 and compares every field in every element to see if something changed there. I mean, like I said a minute ago, it's great for rapid development. You can drop it in, you can go, and you can have something doing something in a couple of hours. But with it doing that on every single everything, every time anything changes, change detection does, anyone who's spent more than 3 hours with Angular knows it can be a runaway train. So there's OnPush. OnPush, rather than working off of deep equality, and rather than evaluating every element of everything, OnPush works by memory reference. So it doesn't look inside the objects. It doesn't care what's in them. It's looking at the actual memory address, which is exponentially faster, insanely faster. But the flip side is that you have to break reference for it to know that something changed, for it to detect a change. But that's pretty easy. When your change detection when it needs a broken reference, the solution naturally is to use broken references. So immutability.js is a great library. Redux, NGRX store, I should say, is a great library that uses immutable under the hood. And then there's kind of hacky solutions. I'm guilty of it myself. I didn't want to put in immutable just now, so I just did this weird thing where I would reassign my response to a new array, and I broke a reference. Woohoo! OnPush works. It's a hacky solution. It's manual, or as manual as code can be. And so you're introducing maintenance, you're introducing workload, which when your app is 1 or 2 modules, 5 or 6 components, okay, great. But once your front end scales and you're dealing with hundreds of modules and things everywhere, that's a lot of room to mess up single quote, double quote, just any little typo. That's a lot of room for human error, which stinks. So there's Immutable, there's Redux, there's these guys that they do the broken references for you, and they let you, Redux especially lets you get to a dumb component tree, which virtually all of your app is dumb. It's not smart. It's not hooked up to your services. It doesn't have any actual connection to the outside world. Rather, your routable components, they're connected to the services. When the routable component gets a response, when it gets new model data, when it wants to update something, it passes it down to the child components. And so there's kind of like the central guy delegating everything down to everyone. Redux, it makes that really easy. I say Witchcraft is what it does because that was my first reaction to Redux when I finally decided, okay, I'm going to sit down, I'm going to get Redux working in Angular. And a couple weeks later, I finally got it working. And once I realized that, hey, this is working. That was my eureka reaction, was I just screamed Witchcraft. And so I just have this permanent tie between Redux and Witchcraft now. Redux is not a simple topic. We're absolutely not going to dive into it here. It's a fantastic thing, but it's a fair amount of work, especially if you're onboarding into something that's already at that 100 modules level. It's already got components all over the place. And backfilling Redux would just be shut your app down for some weeks. So the big benefit of Redux is that it uses immutable.js under the hood. Well, it uses immutability under the hood, and it forces you to use immutable for everything in your client-side state, which once you've hit that point, once your entire client state is treated with immutability, now you can use OnPush anywhere in your app. You can just slide it in, no problems. There'll never be the weird bug where you have to click off screen somewhere to get the UI to update, and life will be good. Now this is to show the difference on how the impact Redux would have on an app. This is kind of a common component tree for, I don't know what this would be making. It kind of looks like a Facebook clone, but maybe just the messages, something like that. I needed something light that only has a couple of components. So we have parent component, we have a sidebar component, we have a user component, and we have two services, people and messages. But there's, I think last I counted, there was 7 connections between the services. So that's 7 places that you have to be conscious of how you're dealing with your data updates. You have to double check every time you want to push to production. It's fragile. There's a lot of room for things to go wrong, which nobody likes. Now, the same app, using Redux, we have 2 connections. That's precisely 2 places where we need to watch things. We have sidebar component and user component. They connect to the store. The store does all the work. It does everything. But it does it in such a fluid way that if something goes wrong, you know where it went wrong. There's no mystery to fixing a bug in a store. And so outside of those 2 components, everything else, it relies on inputs and outputs. In this model, sidebar component, if it gets a new message comes in, sidebar component knows about the new message, it trickles it down through tabs component to the messages component, and messages component shows the update. And since we have 2 connections to the store, the store itself is immutable, and all of these child components are dumb. Whether we have 2 incoming messages or 200,000 incoming messages, the performance difference is trivial. It's several milliseconds to handle the other 199,999 messages. That's the end. So, yeah, let's kind of sped through some things. I expected that to take a whole lot longer than it did. Does anybody want any questions, any curiosities?
Question I got for you.
Can we go back to the pipes slide, please?
Yeah.
I'm curious about the boundaries. I noticed that you have several functions inside this pipe transform. How do you determine how many functions to jam into one space? Is it per component? Is it per behavior? How do you determine those boundaries? Should you use one globally for performance?
Right. The pipe's signature, it needs transform. That's the entry point to the pipe. And inside of that, there's a little nuance of pure functions where generally the rule of thumb is everything needs to be provided to the function and needs to have a clean return. The exception to that rule is a pure function inside can call other pure functions and it maintains purity. So maybe 90% of the pipes that you'll ever work with, they will only have one transform function. But I kind of wanted to illustrate that point about a pure function can call pure functions. And so I basically unnecessarily tacked on another one.
Sure.
Now you could, if you so choose, you could have 100 components or 100 other pure functions inside. As long as they're pure, you can compose them however you want. You can call them from inside that transform function, and you maintain purity.
Okay, so tax for price in this case is basically a private function, private to the pipe transform.
Yeah. Okay. The pipe interface in our front-end implementation, we pass subtotal to the total price transform. which whenever you pass something to a pipe, it's going directly to the transform function. And honestly, I hate the signature of the colons to separate the arguments. I don't like that, but c'est la vie.
Sure. Cool, thanks.
Any more questions? You got one?
So you mentioned we're probably already using pure functions in our component logic. I actually didn't know what you meant at that point was component logic. I'm not an Angular guy, if that's particular to Angular, or if that's more of a design pattern thing, if that's like,
yeah, I use
just mean your low-level code.
I use component logic because, I mean, I am an Angular guy, so I use that term, but it's universal, really. I mean, anywhere you have a chunk of code, you're probably using pure-ish functions there, things that could be refactored to be pure.
Okay. So I mean, what are components? You just mean.
I can get. So, oddly enough, I see better over here. So in the front end, in the build that we were looking at, this is the books list component. What we were looking at earlier is broken out into two parts. This is the front end template code, and this is what I was calling the component logic. It's the thinking behind the template.
Okay.
Now, if you were working with, the same idea applies whether you're working with React. You could be working with, just classic PHP. Anywhere there's thinking behind your front end it's a place for optimization, and purity is a huge optimization.
Right. Thanks.
Or we're good? All right, let's give Kevin another hand. So next week is lightning talks. So if you have one, talk to us. Also, we're still looking for volunteers to replace our Kyle that appeared from the wild. Yeah. But yeah, just message any of the organizers, which include Brett, me, or Andrew, and we'll get you hooked up. Thank you.